In this video, we are looking at A-Level Maths Topic 6, and that is coordinate geometry. As always, these notes will be available on my website, which is linked in the description if you would like a copy. Thank you for watching. Let's get into topic 6.1, the distance between 2 points. So first of all, to find the distance between 2 points, there is an equation that I recommend understanding. Now, I've been very careful with the way I've worded this because I wouldn't recommend just remembering it, because honestly it's a waste of your time. As you can see at the bottom, it is just Pythagoras, but written in a fancy way because you've got the difference between the coordinates within it. So let's just go straight into question number 1, and you will see exactly what I mean. So find the exact distance between -1, -5, and -2, -1. So what we're going to do is we will plot both of these points on a graph. So you can imagine for this, we're going to be looking in the bottom left quadrant of a coordinate axis. So we're going to roughly draw our points in kind of the right areas, but we can just say it's around about there. So we need to find what is the difference in the x coordinates and also the difference in the y coordinates. So what we can do is form a triangle here. So I've labelled on our coordinates, so what we can do now is work out the length of each of the dashed lines. So the difference between -1 and -5 is 4, and the difference between -2 and -1 is 1. So applying Pythagoras, we can just do 4 squared plus 1 squared is going to equal that c squared that we need to work out. Obviously, you can just put this in a calculator. We're going to get c squared equals 17, so c equals the square root of 17, and that is our final answer. That will be the distance between those 2 points. So question 2, similar concept, slightly different wording on the question. A and 2a is a set of coordinates that is 3 units away from 3, 1. Find the possible values of A. So again, with any of these, I'd recommend drawing it out first in a graph. 3, 1, let's call it about there. So because the second coordinate pair is unknown, the A and the 2a, in theory, these coordinates could be anywhere in a circle 3 units away from that coordinate. So rather than plotting all of those, we can probably guess that we will have something up there where that's A and that's 2a, and that distance is 3. That's kind of the thing we're after here. So hopefully that concept makes sense in the way that I've drawn that graph, and the A, 2a could be in numerous places, which is why it asks the possible values of A. This is where we could use the equation and just substitute things in. So notice here how we've got the first pair of coordinates is labelled x1, y1. And the second pair of coordinates are x2, y2. And in the equation, you're taking away the 2 x's, taking away the 2 y's, squaring them, adding them together, and square rooting them. We can do that and just substitute in our a's and our 3 and our 1. So I'm going to go ahead and substitute that into the equation. So once you substitute it in, this is what it will look like. And from here, it's going to be a matter of expanding out the brackets and rearranging it until we get our final answer. So I'm going to expand the brackets. And then we're going to want to take those away to combine them into one quadratic expression. And from here, if we square both sides, we will cancel out the square root, and we can combine it into one big quadratic. So this is part 1 of that step. And this is our final quadratic, 5a squared minus 10a plus 1 equals 0. And this is where we can take our A-level calculators, or if you don't have an A-level calculator, you can use the quadratic formula to work it out. But we can substitute in the values in your quadratic solver of a equals 5, b equals minus 10, and c equals positive 1. And the final answer we get is that a equals 5 plus or minus 2 root 5 over 5. And that is our final answer for this question. That was a difficult question. Please let me know down below if you aren't 100% sure on any of that. Let's move on to 6.2, which is finding the midpoint of 2 points. Again, there is an equation with it, but to be honest, it's normally easier just to draw a graph and sketch it out and then work through it intuitively. So find the midpoints of -1, -5 and -2, -1, the same as what we had before. So let's recreate that sketch that we had when 1 was down there, 1 was down there, and I'm just going to draw that triangle that we had with the dashed lines. Now for this one, logically, we can look at each of the coordinates completely separately, and we know that the midpoint of -1 and -5 is going to sit at -3, and the midpoint between -2 and -1 is -1.5. So naturally, the midpoint of this line is going to be at -1.5, -3, and that is our final answer. Moving on to the second question, very similar concept, just different numbers. If we draw out that axis again and label on the coordinates, we have -1, 4, which is around about there, and 3, 2, which we can say is there. So again, here is our triangle and the labelled coordinates. The middle of -1 and 3 is at 1, and the middle of 4 and 2 is 3. So again, the coordinate for the midpoint is going to be 1, 3. Fairly straightforward. Again, let me know down below if you have any questions. Moving on to 6.3, the equation of a straight line. So it is very important to be able to switch between two different forms when it comes to the equation of a straight line. And to be honest, a lot of it is just your ability to rearrange things. The y equals mx plus c is the standard way that you've seen throughout GCSE, and this way is great for finding the gradient and the y-intercept immediately. However, there is another form to write the equation where it is ax plus by plus c equals 0, and this one can often be a bit easier for finding points of intersection through simultaneous equations, or also the x-intercepts or roots effectively. So here we just have one longer question that covers a lot of it. Find the equation of the line that goes through -4, 3 and 5 minus 1 in the form of the ax plus by plus c equals 0. So to form any straight line equation, we need the gradient of the line and we need the y-intercept, which again normally you'd write as y equals mx plus c. So we're just making a slight change there when it gets to A-level. So as with any question like this, I would recommend plotting them out on a coordinate axes first. So -4 and 3 and 5 minus 1. Roughly drawn accurately, but this is the line that you can kind of expect here. So we know that the gradient of any straight line is the change in y over the change in x. So the change in the y here is the first coordinate minus the second coordinate, so 3 minus -1, and that's going to give us 4 on the top. And the change in the x is going to be -4 minus a 5, which is going to be -9. So our gradient is -4 over 9. As I said, the other thing we need is the y-intercept. Now the y-intercept, you might as well stick with the y equals mx plus c that you've always known. So y equals -4 over 9 x plus c. So now we can just take one of the coordinates and substitute it into the x and y values. So we're going to take the 5 and the -1 in this case, but feel free to try it with any of them. So substituting those in, we're going to have -1 equals -4 over 9 multiplied by 5 plus c, so that c is going to be -1 plus 20 over 9. And this gives us that c is 11 over 9. So now what we can do is effectively write it out in y equals mx plus c. So we have y equals -4 over 9x plus 11 over 9. And because we need to write it in this form of ax plus by plus c equals 0, we can first of all multiply everything by 9. So 9y equals -4x plus 11. And then bring everything onto the left-hand side. So we have 4x plus 9y minus 11 equals 0. And there is our final answer. As I said before, because you in some cases will be using this to find points of intersection and solving simultaneously, it's a good habit to write these where a, b and c are all whole numbers, integers. But that is the end of 6.3. Moving on to 6.4, parallel and perpendicular lines. So all stuff you would have learned at GCSE, but two lines are parallel if they have the same gradient. They're perpendicular if they meet at a right angle. And the bottom point, two lines that are perpendicular have gradients that are the negative reciprocal of each other. A very important thing you would have learned at GCSE, but easily forgettable. So there is a reminder for you. Question number 1. Find the gradient of the line perpendicular to 4x equals 2y minus 3. Again, convert this into your y equals mx plus c. So for a, we can add 3 onto both sides. So we have 2y equals 4x plus 3. And then we can half it. So we have 2x plus 3 over 2. And because here the gradient is 2, the m value, then the negative reciprocal of that is going to be minus a half. And that's our final answer. Again, should be all standard stuff from GCSE. Exactly the same again with this one. We're going to take the y on its own on the other side. So we're going to get 5y equals x plus 3. And then if we rearrange it to make y on its own, we have a fifth x plus 3 over 5. So here the gradient is that fifth. So the perpendicular gradient will be minus 5. And that will be our final answer. Moving on to question number 2. Find the equation of the line that is parallel to 2x plus 3y equals 6 and passes through minus 4, 1. Again, GCSE question. Rearrange the first equation to get that parallel gradient. So 3y equals minus 2x plus 6, and then divide by 3. We have minus 2/3 x plus 2. So here the gradient value, the m, is minus 2/3, and because it's parallel, we want the same gradient. So because of this, we know that our new line, let's call it L, is going to be y equals minus 2/3 x plus c. And the final thing we need to work out that equation is the plus c at the end. So if we let x equal minus 4 and y equal 1 from this coordinate here, we can substitute that in so that L equals 1, which equals minus 2/3 times minus 4 plus c, so that c is going to be 1 plus 2/3 times the minus 4, which if we put that in our calculator, just to get it quickly, is minus 5/3. So our final answer is y equals minus 2/3 x minus 5/3. And you don't have to do this unless it asks you, but it's a good habit to get into. We could rewrite this in the proper form of a straight line, the ax plus by plus c equals 0. So if we multiply all this by 3 and then bring it all over to one side, we're going to get 2x plus 3y plus 5 equals 0. And that is our final answer at the bottom. On to 6.5, which is the equation of a circle. So this might be something that is fairly new to most of you. At a top level GCSE, you would have touched on equation of a circle, but only in situations where the circle is based around the origin, so the centre is 0, 0. That equation looked like x squared plus y squared equals r squared, where r is the radius of the circle. But when you have a non-0, 0 centre for the circle, we have to introduce two coordinates a and b, where a and b are actually the new centre of the circle. So this is the new equation, where we have x minus a all squared plus y minus b all squared equals r squared. First of all, question number 1, let's get used to just understanding how to read that centre and radius off of the equation of a circle. So I'm going to keep the equation here on the screen. Write the centre and the radius of the following circles. Now straight away, the radius here is going to be root 32, which can actually be simplified to 4 root 2 if you apply your standard simplifying surds rules. And the circumference, you can see, is the negative version of whatever the number is in there. So that's going to be minus 4 for the x value. And because the y squared is y on its own, the b value must be a 0 here. So the centre is minus 4, 0, and the radius is 4 root 2. Hopefully that makes sense. Now this one is slightly harder because it involves completing the square, but this is a standard process that you will see a lot of, and you just need to get used to practicing it. So we break down the completing the square into both of the x and the y segments separately, and we do the completing the square rules. So hopefully you remember them. So we have an x minus 4 squared because we half that minus 8, and then we square and take the negative value of the number within the bracket, so the 4 in this case. And then we repeat the same for the y's, so it's y plus 1 all squared minus 1. And then we've got that plus 8 at the end equals 0. So you can see this kind of equation of a circle forming already. X minus 4 all squared plus y plus 1 all squared minus 16 minus 1 plus 8 is going to be a minus 9. And we set that equal to 0. And now we can read this off of here so that the centre of this circle, again, is the negative version of both of the values in the brackets. So the same as when you're finding the roots, effectively. 4 minus 1. And because the 9 should technically be on the other side, the radius will be 3, because remember, the r squared is the bit on the right-hand side, so the radius is going to be the square root of that. And on to question number 2, slightly harder. A circle with centre 3 minus 5 and radius 7 crosses the x-axis at points P and Q. Find the distance between P and Q. So, a circle with centre 3, 5. First of all, we write that equation out. So it's going to be x minus 3, because it's always the negative, squared. And then the same for the y's. If it's a negative 5 coordinate, it's going to be a plus 5 in the bracket. And then 7 squared, which we could just write as 49. So there is our equation of this circle. And we want to find out when it crosses the x-axis. Now, an important thing to remember, it crosses the x-axis when the y value is equal to 0. And that's standard for any type of line or curve that you're trying to work out. It's the same way we set the equation equal to 0 when we're factorising a quadratic to solve it. But what we can do here is substitute 0 into the y value. So we have the x minus 3 squared plus, and this bracket is simply going to turn into 25 because we've got a 0 going into there. So now we can expand out this bracket. We have x squared minus 6x plus 9 plus 25. And then we can also bring the minus 49 onto the left-hand side. And simplifying all that together, we have x squared minus 6x plus 9 plus 25 minus 49. And then the constants will come together to make minus 15. And what we can do is we take the a, b, and c values from here. So a equals 1, b equals minus 6, and c equals minus 15. Plug that into your quadratic solver within your calculator. And we get the two x values are 3 plus or minus 2 root 6. Now the question is asking, find the distance between P and Q, those 2 points. So because both of these are on the x-axis, you can imagine it like this. We're going to have 3 plus 2 root 6 that way, and 3 minus 2 root 6 on the left-hand side. So all it takes is 3 plus 2 root 6 minus 3 minus 2 root 6. So these two are going to cancel, and the double negative is going to give us a final answer of 4 root 6, and that is our final answer. Hopefully that makes sense. Any questions, let me know down below. So moving on to the final subtopic of this topic, which is 6.6, solving problems with lines and circles. First of all, well done if you've made it this far, but let's get into it. Problems involving curves, lines, or circles usually require finding points of intersection. And a very useful way to find out how many points of intersection there are is with the discriminant. And this is something that we covered in topic 3, which was the quadratic functions topic. The little diagram I have at the bottom just shows if you have a line, and that line could be a curve or a straight line, it doesn't really matter, the circles can interact with them in 3 different ways, as you can see. We can have 2 intersections where it goes straight through. We can have 1 intersection where it is a tangent to that circle, or 0 intersections. And as I said, it all links back to using the discriminant, because if you remember, the discriminant has 3 rules. If b squared minus 4ac is either greater than 0, equal to 0, or less than 0, that will indicate which case you have of these 3 here. So anyway, let's look into question number 1. So we have a line, 3x minus y equals 3, is tangent to the circle with centre 5 minus 1 and the radius r, and we need to find that r. So first of all, let's rearrange that line to be in the form y equals mx plus c, and that is going to look like this: y equals 3x minus 3. So now we just know by looking at it, it's got a gradient of 3 and a y-intercept of minus 3. Let's also put together the circle. So the centre 5 minus 1, please pause and give this a go, because the more practice you get, the better, is going to be x minus 5 all squared plus y plus 1 all squared equals this mysterious unknown r squared that we need to work out. So the other thing we can use is that these 2 things are tangent to each other, which indicates that they will meet, first of all, but when they do, the discriminant between that quadratic is going to be equal to 0, which will hopefully give us an equation that involves the radius that we need as the only unknown variable. So that is the kind of thought process going into this question. Now, to find out the points of intersection, or the quadratic that will enable us to work out the points of intersection, is by solving these 2 things simultaneously. And conveniently, with this one equal to y, we can take this 3x minus 3 and substitute it into that y variable there. So that's exactly what I'm going to do. So x minus 5 all squared plus 3x minus 3 instead of y, and then plus the 1, and then we wrap that around with the squared bracket, equals r squared. So tidying this up a bit, x minus 5 all squared plus 3x minus 3 plus 1 is a minus 2, and then that's equal to r squared. Our next step is just to expand those brackets and combine it into one big quadratic. So x squared minus 10x plus 25 is the first quadratic, and the second one will be 9x squared minus 12x plus 4 equals the radius squared. So combining all that together, If we add the two x squared terms, we're going to get 10x squared. And then we have minus 10x plus minus 12x, which is minus 22x. And then 25 plus 4 is 29. And we can also bring that r squared across to the left-hand side, making it negative. And as we've done throughout this series, it is very important to become comfortable identifying the a value, the b value, and the c value before it goes into the discriminant. So obviously we've got 10x squared, we've got minus 22x, and the c here is actually going to be that whole 29 minus r squared equals 0. So before we go on to that next step of plugging it into the discriminant, we can just make a note here. A equals 10, b equals minus 22, and c equals 29 minus r squared. Just makes it really clear to any examiner that you know exactly what you're doing. Anyway, we know that b squared minus 4ac should equal 0 because it's a tangent. So plugging that in, we've got minus 22 all squared minus 4 lots of 10 times 29 minus r squared is equal to 0. I would recommend using a calculator just to make sure you get all of these numbers correct. So 22 squared is going to be 484. Minus 40 lots of 29 minus r squared equals 0. Again, purely to stop yourself from having to deal with the big numbers, we can divide this by 4. So that's going to leave you with 121 minus 10 times 29 minus r squared. And then if we expand out that bracket, we've got 121 minus 290 plus 10r squared is equal to 0. So taking this into the final part of this question, we're nearly at the final answer for r. So 10r squared is going to equal 169, such that r squared is 169 over 10, and then r is going to be the square root of those two, which if we put into our calculator will give us our final answer, which is approximately 4.11. And obviously when it comes to this kind of stuff, because we're expecting a radius, which is a measure of distance, we want to make sure it's a positive number. So always bear that in mind. If you do get a negative, you can either discard the negative if you do have a positive, or if you only get a negative answer, you may have made a mistake somewhere. So think about that answer and go back and double check. But that sums up the end of topic 6, which was coordinate geometry. Thank you again for watching. Please consider giving this video a like and subscribing to the channel if you did find it useful, as it massively supports me. But apart from that, I will see you in the next video.